Hey YouTube, it's Dimitri, and today we're going to cover the first video in our model development series on data cleaning, anomalies, and structure. So there's going to be at least 2 videos on data cleaning. Just as a disclaimer for all the videos in the model development series, these videos are not the end-all be-all. I could actually probably write an entire syllabus and make one entire semester's worth of classes only on data cleaning. But again, these are only going to be short videos on more or less what to think about, how to get going, and different key issues that you need to be aware of. So first off, you have to get the model assigned to you. Typically in a work environment, you will have somebody who will assign you a model. So they'll say, hey, Dimitri, or, hey, your name, you will be assigned this model. You will need to create a model for this. That's the model assignment. If you work in something more or less like a trading floor, you run your own YouTube channel, such as I do, or you have another need for a model, you're going to be assigning the model to yourself. And so this is the first step, is getting the model assignment and figuring out what you are going to model. So the second part, now that you actually have the model assigned to you, is gathering any and all information regarding your target variable or your dependent variable. So since you're going to model something, you need to go out there and you need to learn everything you can about this. We're going to state right from the beginning, don't blindly just throw data in and say, hey, look guys, I created an OLS model, or hey, look guys, I created a logistic model, and then just throw crap in and go, look, it has a great R squared. Thumbs down, you suck, you failed already, your model is not good. So again, you need to gather as much information about what you're modeling as possible. The reason we do this is because there's a lot of different caveats about what you do and don't know, and a lot of times these will come back to bite you. One example is that I've seen models more or less where people build them. The user specifies that there is seasonality involved. The developers do not consider the seasonality, and more or less the model sucks, it fails. And you might say, but Dimitri, it fits well, it looks good. That's true, but when you got the model, part of the assignment was looking at seasonality. So I need to see that you looked at seasonality, you considered it. If it's not actually there, it's not statistically significant, then feel free to leave it out. However, if they specify it's in there and they need it, and you test for it and it actually is there, then it should be in the model, and we'll cover that in later videos. And this more or less leads into the model requirements and uses, and so there are many things you need to consider. First off, whoever is actually asking you to build the model, whether it be yourself or an actual model user, you need to make sure that all the requirements are met. So I mentioned seasonality. They might have variables that they think should go into the model. You should talk to them about this, gather the variables, make sure you're meeting all the requirements they have. And then for people such as myself in banking, you have regulatory requirements. So some things can be used in models, some things cannot be used in models. It is illegal and against specific laws to use specific variables. And so knowing exactly what you can and can't do will help you define your model search. It will help you build the model better and make sure that the model you're building actually fits the final use and doesn't fit more or less your opinion or just this very general broad model that isn't built for the exact purpose that it is needed for. So after the model is assigned, we're going to jump right in here to data cleaning. So exactly what is data cleaning? Well, let's jump through a few examples so you can see exactly what I'm talking about. So first off, you need to gather your data, and there's typically 3 different sources. There's internal data, which you typically gather from your internal sources, your business, your MIS systems, basically anyone that's internal data that you can gather for your model. The second one is vendor data, and this could be anything such as Moody's, for example. In finance, we purchase data from Moody's and we use Moody's data. It could be also credit information about credit bureaus, so you could use Experian or TransUnion or Equifax. Those are 3 different examples of vendors who sell vendor data. And the third one, which is becoming more popular, is public data. So you can go online and you can Google like economic data, and it's just made publicly available. I wouldn't say it's a vendor because you're not paying for it. It's definitely not internal data, and so this is just publicly available data that you can download online. So data cleaning in itself is an entire process. There are many, many things that can go wrong with it. I'm just going to cover a few issues, a few examples for you to look at and to consider. However, all data is different, and there are different considerations for different types of data sets. So as I've listed here on the slide, there are 6 things that I like to look for in data. Again, if I see other things, I do other testing, but these are just the general 6 that I like to look for. I take the min, the max, the mean, I plot distributions, I compare actual data values, and I do actual plots of the data in itself. So all 6 of these different items can give you information about the data and help you catch issues with the data. However, these don't guarantee that you do or don't catch issues. And as I've seen online, as somebody else mentioned, having dirty data, especially in like the new world of like machine learning, the biggest problem or assumption, so yes, you can be breaking assumptions before you even get going with the model development, is that your data is clean. Machine learning is focused on data and data in itself. All models in general, OLS, logistics, time series, all those different types of models all depend on the data. And as they always say, garbage in is garbage out. So this is very important that you do the data cleaning correctly, or if not, you might end up with different results than somebody else. So there are 3 basic methods to actually cleaning data, or at least 3 different approaches. There's manual, sampling, and semi-auto. So these are 3 different approaches. We're going to run through 3 different examples on when you would use them and why you would use them and the pros and cons of using these. But let's dive on in now to the manual portion. So for the manual data cleaning, this is very tedious. You would actually go through each cell and look at each cell and come up with if it looks reasonable or not, and then you just move on to the next cell. The example here you'll see is YouTube data from my channel. This is just a snippet of it, but the issue is that the data is small. There's only 66 observations and there are only 55 variables, and if you're building a model and let's say you're only using 10 out of these 55, then you could do data cleaning and it would be pretty quick to visually check these and do a manual review of the data. So manually reviewing data is not very practical. However, if you do have small series or if you're doing time series, which in general are smaller, doing a manual review can be a good idea and can save you a lot of time down the road. So as I mentioned, there are 6 different tests I like to use to actually test data. Doing the mins, the max, the means, distributions, comparing and actually plotting. Here you can see an example in the manual portion that I actually found a missing value. It's for the video length and the video created. These are just 2 variables I ran a quick analysis on. You can see that I am missing 1 observation. And then also you can see here when I take the min on card clicks, there is a -10. This isn't actually an error. I created this error just to show you. But you can also see from the min value, you need to think logically, like on card clicks, is it possible to click -10 times? The answer is definitely no. But again, you need to understand your data to know that. And then also here on the right, you can see the card clicks plot. So I just plotted these out for all the videos I have data for. And then you can see the 1 bar drops below. It looks suspicious. And so therefore you should dig in and figure out why that's happening. Again, in this case, it should not happen. It's an error I created just to give you an example of what is wrong with data or can be wrong with data. To go back up to the missing though, the reason this is missing is I actually have a private video. So it's not published publicly, and since it's a private video, they don't give you the information on the video length or the video created. So again, this is a missing one. If you're actually cleaning the data set, I would remove this entire observation, as this would not be a good indication of building revenue, video views, content creation, looking at a variety of different things such as your CPM. These aren't going to be good in a marketing analytics perspective because this data is missing a lot of variables and a lot of values just because it's private, and my video in itself is not targeting private videos. Like I only share these with friends and family, so there's no reason to include this in a marketing analytics scenario. The second one is sampling, and so in this example, there'd be credit consumer data or just credit data in general. For those of you that don't know and don't work in finance, credit data can be millions of observations long. In this sample, I'm just showing you there is 100,010 observations or rows. There is 1,200 variables. So doing manual sampling is not even feasible. It would take you months and months and months. And at the end of the day, you're probably gonna get lost and confused and it'd be a waste of time to do manual. And so manual is not very popular. However, in sampling, again, you can do doing the mins, the maxes, the means, looking at missing values, for example, all very crucial in looking at it on the entire data population. But sampling in itself is a good idea. So what I like to do is actually sample the data. So if I have 100,010 observations like in this one, I would sample out say 20 or 30 values just to look at the data and figure out what is going on with it. So for example, we have the origination date, we have FICO, we have income, we have BAD, and we have 30 DPD. The sampling approach gives me a chance to look at the data, figure out what's going on, logically come up with what should be in each value. So after you run those mins, the max, the mean, you plot out the distributions, you look at the plots, you can actually compare this as well, but not in this example. You can look at these and figure out like, okay, the FICO score, for example, has to be between 350 and 800. So if you took them in and you ended up with a 280, you know something's wrong. But again, if you didn't take a sample of this data, you'd have no clue what's actually happening. 280 would seem reasonable because you just wouldn't know. And a lot of times your variable names aren't going to be very descriptive. And so you might have something that's like, I don't know, B underscore all underscore FICO underscore date or something. You might have something like really crazy thing and FICO's part of that. And realistically, that variable should have just been named FICO. But since they named it some crazy long name, you might not know what it is. And so doing this sample and just taking a snippet of the data in itself is a good idea. And I call this the sampling approach. But again, you still need to run the min, the max, the mean, and look at all these different graphs and plots to see if there are issues visually and numerically. So a great example of this, like I said, is that I used credit data. So let me just throw a disclaimer in here, guys. All this data is completely made up. The credit data is 100% made up. I'm not using any real data as I have no access to any of this type of data. However, I'll give you a general idea of what it looks like and more or less the errors that you might see. So we first did a missing count and we found out that there is 10,000 accounts missing. So out of 100,010, this is approximately 10% of the values missing. This is a crucial issue. We'll discuss this in the next video on data cleaning, but it will be more or less on what to do with these values. But 10% of your data is missing. This is a serious problem. There's a few different approaches you can take to handle this, but again, we'll cover this in next week's video. The second issue is I checked the min, and again, we have no negative values, which makes sense for income, and so income comes out having great positive numbers, but the min was 2,800. So the question is this a real value? And the answer is, it depends. It's not as simple as just saying like, oh, that's not possible and throwing it out. You might have had somebody apply that more or less has like a part-time job and that's it. And maybe they don't make much money, and so you might want to keep this value in. However, you need to do a little bit of research and figure it out. In the model in general, though, if this is the only point and you have 110,000 or 100,010 observations, and there's only one of these that is this low, which can be seen on the graph on the right. So in this case, I would probably throw out this observation because there's probably no way for us to actually find out if this is an error or not. And if this is the only one, so like the next closest min, let's say is like $29,000, clearly this seems to be an error. I would just clean it out because we have 100,010 observations. There's no reason to actually keep this value in there as it's not going to add a lot of value in itself. All right, so semi-auto data cleaning. This is not very popular. The sampling is a great way, I think, to do data cleaning. It's probably the most popular I've seen. Again, all these are just kind of general approaches. Most people, though, actually just run the min, the max, the mean, and then they blindly go through it. Again, I like to use the sampling approach most often just so we can get an idea of what we're looking at before we consider if min, max, mean, distributions, and plots all make sense. But semi-auto is not popular, and it is by far one of my favorite, but it has a very specific use. So what is semi-auto data cleaning? Semi-auto data cleaning refers to using automation or programs that just go through and look at everything and catch errors and flag them on their own. One example of this is I actually built a program that did this. I won't say what type of data it was, but it was a vendor data. The vendor data was historical data, and then it would be updated every, say, 6 months to a year or every quarter. And at the end of the day, it would just add data on top of that. And so what you would have to do is actually go through and check all the historicals and make sure the historicals made sense. So now you're probably thinking like, Dimitri, this doesn't make any sense. It's historical data. It would never change. But different vendors will actually rescale or re-anchor their data. And so there are different things to consider. And when these get rescaled or re-anchored, sometimes you'll have data that's historical and they'll rescale and say like one specific year. So say in 2000, they rescaled to a base of 100 and you'll have a jump. And now the new data might be scaled at 100, but the old data, since it was not scaled, might be a lot lower than it was originally. And when this happens, it creates errors in the model because now the data isn't consistent. There's two different states. And so semi-auto is I actually created a program that was completely automated that would go through and take an old data set that we had that should technically match the new data set. It would trim off the new future data points that were added, or the most current ones. It would compare the two historical values together, check to see if they were matching or not, and then if they were, it would create a flag. So the hard part was actually checking the future data, or the more current data that was appended to the historic data. The reason is you want that in line, and like I said, you don't want to jump in data. And so what I would actually do is the program would automatically go through and check the growth rates between each data point. If the growth rate was larger than some threshold, which you could specify, it would flag a variable and say, hey, something could be wrong with this variable because the growth rates seem to be different than they were in the past. And so the key, though, is that this model was not well accepted by corporate because they had 1,000,001 questions and they couldn't figure out why it wasn't fully automated, meaning you just blindly run this program and it would create great results. However, the semi-auto part is that you can adjust the thresholds, and this is important because not all data is going to have the same threshold. So for example, GDP and disposable income might have different growth rates. And so if you would set a threshold to say 2%, like anything greater than 2% is unreasonable, which would be somewhat reasonable maybe with GDP, maybe 4%. Something like that would actually be good, and so it'd be a great threshold. But if you had something such as disposable income, and you have like a crisis or something, you might have rates that are growing at like say 10% or 8%. And so setting that threshold at 5% would flag literally half your variables because the issue is you don't have a good flag or a good threshold set in the model. So semi-auto, though, is a great way to do data. In this example, there is 161 observations. It is time series data. There are 300 variables. And this example would be economic data, as I mentioned in the actual program that I developed. Again, here's a good example of more or less a mistake or a little bit of a scaling change. And when you look at this plot on the left, you can see the historicals match up perfectly, so it would pass this part of the semi-auto data cleaning. However, when the new periods are appended on the end, you can see in the plot that they're slightly different. And this is more or less a scaling. And if you consider at this point that there was a scaling happening, you'd catch there would be no big deal. The other issue to consider is if, for example, say the orange line didn't exist at the end, but only the blue line existed, how would you know they were rescaled? The thing is, you might not catch this. But again, you need to check growth rates and look at the differences between the data in previous periods and in current periods to catch this. So in this example, I caught two different issues with GDP, both real and nominal. And you can see the real GDP growth is plotted here on the left. And visually, you can see the mistake. Also for missing, I just ran a quick missing one on our GDPG, and there are 0 missing, so that looks good. That's consistent, as this is time series and there hasn't been missing values in the past. There shouldn't be missing values in the future. If there are serious questions that need to be arise and what to do in time series, as you have to have every single point to actually build the model. And then also something else is when you run your future rate issue. So I set my flag at 5%, and let's just say that the triple B yield, which is an interest rate for triple B rated corporations and debt, is 5%. So if that threshold is set that no point should be greater than 5%, and it was flagged and this one variable came out, then you would want to go back to visually viewing the data, running the min, the max, the means again, re-reviewing what you have, and making sure the data is good and consistent. Checking to see where that 5% plus growth rate is. Is there a spike somewhere that it shouldn't be? Is there a reason for that? Does it look like a shift? And at that point, you'd go back and talk to the vendors. If it's internal data, you'd go back and talk to the businesses that collected this data and figure out why this is happening. And if it's public data, there's really not a lot you can do, but you might consider leaving this into a development sample and cutting out that middle piece and then trying to find a way around this. And time series, again, you can't really slice and dice as you need all the points to make the time series model. But in other methods, you can actually split different areas. So you could have a development sample, for example, in credit data, say from like the year 2014 all the way through the end of 2014. If you had an issue, say in January, February of 2015, you might skip 2015 and then use 2016 as a full year as your out of time sample. So now kind of as a final wrap up on this, on the data structure and processing, you want to merge all these different data sets together. So you might actually be merging different types of data together. You could be merging vendor, public, or internal, or you might have multiple data sets that are all from one type. So for example, it is common to have 2 or 3 different data sets that are internal data sets that you're merging together. And so you need to merge all of these together at the final, make sure the merge is correct. That if you have different observations lining up, that they need to be lined up perfectly, because if not, you're going to have bad data and a bad model. And when you're creating this final data set, you need to make sure that you have the target variable that you're actually going to model it, or the dependent variable, and also check for all the independent variables that you're going to be using in the model itself. Something else that new developers typically miss is that you want to keep benchmark variables and challenger variables. And so you might ask me, Dimitri, what the heck is a benchmark or challenger? A lot of times when you build a model, there are other similar models for other similar products or other different areas, a different model somebody has built. These can be considered benchmark models or challenger models. And you want to be able to compare your results to other people's results to more or less see how accurate your model is, if it's performing as expected, and if it's not, why is it not performing like other models. However, when you create this final development data set, which is what we're working on, you want to make sure that you have everything in it that you need in the future. Any analysis you would ever want to do, you want it in this data set. Don't trim out everything and make it a nice, pretty, clean, small data set at this point, because at the end of the day, you're going to need stuff later down the road, and it's definitely modeling best practices to keep it as much as possible until you get to more of the computational section, and then you might create sub data sets that are trimmed down to do massive computations, which is very, very common in credit modeling, because like I said, we might have millions of observations and thousands of variables, and like, I don't know, I've seen a data set that was 100 gigabytes, so you can imagine running calculations on this takes forever. And so at that point, you would trim down a smaller data set. But at this point, we're just cleaning data and getting to the final data set that's going to be used for the modeling function. And to do that, you want to make sure you have everything you're ever going to want or need in this data set. So that's basically it, guys. That's the first kind of data cleaning video, which is on the anomalies and structure of the data itself, finding small mistakes. We're going to move on to a second part of data cleaning, which will come out in a week from today. If you have questions or comments, please list them below. And as I've mentioned, this is not a end-all be-all kind of class or series. These are just quick overviews, so these videos don't end up being 2 or 3 hours or even like semesters long worth of material, as I mentioned in the beginning. But as always, guys, thanks for watching, and don't forget to like, share, and subscribe. Thanks for watching my video. If you find it helpful, please like, share, and subscribe.